All right, worksheet 4.5, graphing three-dimensional. You no longer have points x and y, you have x, y, and z, and we have this funny looking plane like this. But let me make a connection for you to a regular xy plane. So on a regular xy plane, let's say we're graphing points 1 and 2, or another example would be -2, -4. So let's look at 1, 2. You go which way, right or left first? To the right. That's the positive x, correct? This is the positive x. So what if I took this thing and I turned this graph like this? I still want to graph, actually I'm going to turn it like this, 1, 2. I still want to graph 1, 2. So where do I go? Up, down, what? Bottom left, right? So I go over 1, and then I go up 2 in the y direction, so that would be right here. Does that make sense? Okay, if I want positive 1x, positive 2y, here is the positive x, and here's the positive y, even though I've turned the graph around. So 1, 2 would be 1, 2, and then even if I turned it this way, that would be 1, 2. If I wanted -2, -4, I would go -2, -4. Does that make sense? Yeah. What I've done? Yeah. Okay. So now let's look at it this way. Instead of just x and y, you now have x, y, and z. So I'd go 1, 2, and in the z direction would be up here, right? So if I wanted to graph 1, 2, 3, I would start right here. I would go over 1, down 2, and then up 1, 2, 3. Does that make sense? And it would be right about there. But can you see this third axis that goes straight up and down towards the camera? No, you can't really see it. So here's what happens. Here's the x, here's the y, and here's the z looking right at you. Got it? See it? So what we do is we first turn it this way. You still can't see the z, and then we lean it back like this. So you see the x, the y, and then the z going up. Okay? So 1, 2, 3 would be over 1, over 2, and up 3. So how do we see that here? We have to go 1 in the positive x direction. So if I start here, where am I going? Upper left, upper right, lower right, up or down? Lower left. Right there is your positive x direction. We've basically taken this axis, turned it this way like this, like I just showed you. You have the z-axis, and then leaned it back a little bit like this so you can see the z-axis going up and down. There's that z-axis going up and down. So positive 1 is over 1, but follow this x-axis. See that dot right there? That would be over 1. Now I have to go 2 in the y direction. Follow the y-axis right here. So this would be over 1, 2 right here. And then I have to go up 3. Follow the z-axis. See, right here on the y value, I didn't stay on the y-axis. I went parallel to it, right? So if I want to go up 3, do I go up 3 right here on this line? No, go up parallel to it. So right here I go up 1, 2, 3. That's the point 1, 2, 3. All right? So this is point A. I'm also going to show you point E. Okay? And then you can do the rest. So point E, -2. So I start here and I go backwards 2 along the x-axis. So I go 1, 2 backwards, -4 along the y-axis. So here's the positive y. So this way would be negative y. So I would go 1, 2, 3, 4, and then I need to go down 2. So I went 2, 4, and then down 1, 2, right there. That thing's like backwards 2, backwards 4, and down 2, right there. Sorry, down 2 would be 1, 2 right here. Right there. But it's not on that line, it's back behind it. It's that point right there is kind of like back behind the line. Like here's the y-axis. We went 2 this way, 2 that way, and then 2 down here. So it's like we're looking at it from behind there, but it's not there. But it looks like it's on that y-axis. Okay. So that point right there is point E. All right. All right. So that's the three-dimensional graphing. Let's take a look at these set of problems right here. If you look at the first two equations, you notice they both have x and they both have y. So for the moment, we're going to start with just these two equations. What could I multiply one of them by to get rid of something?
3.
I will multiply by -5 so I can quickly get rid of the y. You can multiply the top by 2 and the bottom by 3 to get rid of x. But I'm going to multiply the top one by -5 first. So I get -15x minus 5y equals -15. And I'll just bring this one over. 2x plus 5y equals 2. Doing combination, I will just add them all together. So I get -13x equals -13. So x equals what? 1 is correct. So I have one answer of a 1. Now I can plug the x back in anywhere and find another value. What should I plug it into? First, second, third, fourth, or fifth equation? Actually, the fifth and third are the same. It would be easiest to plug it into the first one. But you can plug it in anywhere. You could plug it in here, but now I have a y and a z left over. I just want to plug it into one of these first two. So 3 times 1 is 3, plus y equals 3. So y equals 0. So I have 1, 0, I now have a value for x. I have a value for y. I'll plug both of these into here so I can find the answer for z. X is 1. Y is 0. Minus 2z equals 5. Subtract 1 from both sides. Negative 2z equals 4. Divide both sides by -2. I get z equals also a -2. So this is the point where everything would intersect. And that would be your answer to these 3 equations in 3 variables.